Hey guys, Button25 here, watching the launch
back in France, at ESA headquarters in Paris,
of the Vega, well, the launch of Aeolus, probably mispronounced that, atop of Vega. Yeah, that thing.
To all of you watching on the internet,
hi.
Also, we all hope you're enjoying the evening. We're going to cut away and let you enjoy the liftoff. You will hear the DDO call out the final 10 seconds and we'll be underway. Enjoy the liftoff, everyone.
Start counting. And please no last minute hold. Knock on wood.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
And this is going to be off like a shot. And yeah, there's no spool up time like on the Ariane 5. This thing is an SRB, so just bang, it's off. It's gone.
La propulsion est nominale.
Look at that fucker go. Yeah, Aeolus is an Earth observation satellite, so I presume it's going to be going into a polar orbit. Because it's apparently predicting wind, or observing wind, or something I wasn't really properly paying attention. I'm sorry. I did miss a bit of the broadcast early on, so.
I'm always amazed. It took her about 3 seconds to cross my computer screen here. 3 seconds, rising like an arrow. Surprisingly fast if you're used to watching the Ariane 5 liftoff. Ariane, of course, raises into the air much more slowly, weighs 6 times.
Yeah, that's why. It does have more thrust, but not that much.
Fine shots of her rising into the light clouds.
You'll watch as we get further, or as Vega gets further up.
138 tons of lift-off from French Guiana, beginning the 12th mission in her career.
And about 2 minutes in is going to be the separation of first stage.
138 tons, but I guess that's relative.
Yeah, compared to other ones.
First stage is burning now. She weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant in any system that we're using today. The first stage burns its single engine for about 2 minutes before being jettisoned.
I presume it actually burns for less too. They just need to.
Because visibility is pretty good.
SRBs have a bit of residual thrust, and they have to wait for that to.
Plant here, where it's loaded with fuel and transferred to the booster integration building. You probably saw some of that on the video on the launcher.
Okay, I think that's the separation there.
Having returned with a big smile on his face.
Yep. And ignition of the upper stage.
Martin Caspers. So, how is it?
Incredible. Tell us. You see it, you feel it, and all the emotion that comes loose. It's great.
And then it's gone.
No, it's not laughed. Yes, it's laughed, but also cry.
Did you cry? Did you shed a tear?
I did shed a tear.
That's good. What
did you shed a tear? Yes, I did. That's great.
The light was so bright, I had not expected that from such a small launcher. I saw the Galileo or the Ariane launch, but this was much brighter than I had expected.
It's like Times Square out there. You can read a newspaper. All right, very good. Come down and watch a launch, folks, if you haven't already. First stage separation.
Not an option.
The second stage is burn. We're into the second stage burn, called second stage the Z23, Z for Zefiro. Burns its solid rocket motor for 86 seconds. Avio, of course, responsible for production, integration, and testing of both second and third stages.
Propulsion du Z23, parfaitement nominal.
Vega's launching north, going into a sun-synchronous orbit. Why do we need that sort of an orbit?
We need it for Aeolus, for the instrument for Aladdin. We want to have a dusk to dawn orbit so that we're always in the sunlight, and it's also the best way to measure the wind profile.
And the orbit is called, they have a name for it, it's ball of yarn orbit, right? Explain that to us.
It is basically, you go north to south pole while the Earth is rotating underneath.
Z23 separation and Z9 ignition. I think it's Zefiro 9,
you saw
but...
separation of the second stage. We're waiting for confirmation by the DDO of the third stage, ignition of the third stage.
Yep. And fairings should be going soon.
Coming up next, separation of the third. All right on time.
Oh god, I don't know why, but that French...
Exposed to the elements, the right On the right, the round.
I love how the
white section.
fairing animation just stopped working.
The cubicle
Like,
and the white
currently,
part of it.
currently the space are just being followed by a pair of
So
fairies.
she needs no more protection from the atmosphere. She's getting her first taste of space.
Of space, but not the first taste of vacuum. She was tested at Diesel, Belgium.
Right, we have a story about that coming up. First, we're used to seeing, here's a question for you, commercial satellites, 15-year lifespan, maybe more. 3 years for Aeolus. Why is that?
Well, Aeolus is one of the Earth explorers, and it's also a technology
Near
demonstrator.
the
And because of
San
the small
Hubert is in
size, we have
France.
less fuel
My
on board
brain,
than the
geez,
telephone
Canada.
satellites have.
Right. So, how much fuel, roughly?
We have about 266 kilograms of fuel on board.
La propulsion du
For a
C09
three-year
est
mission.
nominale.
And the other thing is geostationary satellites at geostationary.
No, why is that?
Because they are geostationary, so they've got.
Because they don't go round in
They
the
don't
ball of
go
yarn.
around. Exactly.
Okay, very good. Another question for you. Aeolus is riding inside the Avum, that's the upper stage. What is Aeolus doing now? I ask you because sometimes satellites are launched on internal power, sometimes they're not on internal power. There are two schools of thought, and there are advantages for both sides. What's the case today?
Well, for Aeolus, we are on internal power since about 10 minutes before launch. So we made sure that our baby is awake and running its own internal processes.
And what's the advantage to that?
The advantage is that we know that the spacecraft is on. You can also switch it on in or do a telecommand. But then, if you miss it, it will not go on. The disadvantage of what we're doing now is that you're on internal power, so you're draining the battery.
You're using power.
Exactly.
Yeah, but I guess there's a case to be made for both sides. That's a hot debate in the space industries.
I presume that's a
Vega
deliberate
means,
intention,
excuse my Italian, Vettore Europeo di Generazione Avanzata.
but I presume it's to not
Advanced
boost the
Generation
axis too much. It's to
vehicle.
kind of circularize the orbit a bit.
The light launcher is
At a guess.
of the Ariane family.
Et
Coming up on
séparation de
separation
l'étage Z9.
of the third stage. Oh, you are right.
Yeah, they don't actually separate that
Confirmation
quickly.
from the DDO. Now, what's left of the composite? On the left, the triangular bit is the Avum, the triangular white bit. The gold box in the middle is what?
That's what we call the platform. So that's basically containing all the equipment to keep the satellite in the right
L'orbite à la
orbit.
séparation du Z9
And you
était
can still see
nominale.
the composite on the right of your screen, and of course the spherical, the oval white on the bottom is the
Telescope. The telescope, which is part of the instrument, Aladdin.
Aladdin. Very good. We'll have more on the instruments coming up later. We have been picked up by our downrange tracking stations.
In
There's
Bermuda.
one here in Galileo. The next one is in the Bermuda Islands, where there's a NASA station. Bermuda will be tracking the launcher from the first Avum ignition to its cutoff on the first pass around the Earth.
Début de la manœuvre d'ondulation avant le premier allumage de l'Avum.
You see the composite being spun up before the first ignition of the Avum. The first ignition, a long one, lasting about 8 minutes. There will be another one later on, a short one lasting about 20 seconds. Tell us about some of the other stations. I know there's some stations far north, Norway, Sweden, and Antarctica, that are going to be picking up the signal after the Bermuda station.
Yeah, so we have one telemetry station in Kiruna, Sweden. That is where we upload data for the control of the spacecraft. And then we've got two ground stations in...
There's the, while you're thinking, there's the beginning of the first Avum burn.
Okay, one is in Svalbard and the other one is in Troll, and there we download the science data from the spacecraft.
The Troll station in Antarctica will give us the final acquisition of the signal later on. Vega's history, briefly. It's interesting, though. She grew out of an early U.S. missile called Scout, you may remember. Italy used the Scout from the 60s through the 80s.
I think at the moment we don't actually have telemetry.
Yeah.
Sounds familiar, anybody?
Sort of on the flight path tonight, north over the east coast of the U.S. Then she launched from the San Marco platform off the coast of Kenya. This was an old oil platform, if you can believe that, on the equator. Like Kourou is near the equator. In 1992,
So, you know,
Scout production
if
was
this
closed
is a
down, but
repeat,
the project continued as an Italian venture called the San Marco Scout, led by Ozzy the Italian Space Agency, and Avio. So you see, Avio has been involved since the beginning.
Des mesures par la station de Bermude.
DDO says Bermuda is picking up the signal now. Our next film, a look at Aeolus close up.
Okay, at least there are DDO announcements this time, maybe it's just the animation.
In August, the European Space
But I'm
Agency
still
will launch
not
its
letting
latest
Ariane
Earth
off the hook.
Explorer mission, Aeolus.
No.
The mission aims to further
Fool
improve
me
our
once.
understanding of winds and help increase the accuracy of weather forecasts. But this new satellite is unlike any other. For example, its shipment to Kourou is by boat rather than plane, because the sudden increase in atmospheric pressure upon landing could damage some of its delicate instruments. Aeolus is also the first space mission to acquire wind profiles on a global scale. This wind data is needed
Still
to
haven't
create
got a
weather
signal.
forecast
Or
models.
telemetry, sorry.
Today, meteorologists have to analyze winds by using weather balloons, tracking clouds, measuring temperature and looking at sea waves for surface wind. These methods, however, have severe limitations and give insufficient data.
All of these systems are not measuring all over the globes at all out from the surface all the way up to the top of the atmosphere. And in order for the model to get the winds right, they need more observations. And this is where the Aeolus satellite will come in. Aeolus will measure winds from the surface or from optically thick clouds all the way up to 30 kilometers and filling a gap in the current observing system of the Earth for forecasts.
To detect these wind profiles from space, Aeolus uses a powerful laser called Aladdin,
Oh, there we go, we
which
regained
stands for Atmospheric Laser Doppler Instrument. This instrument ejects an ultraviolet laser beam through the atmosphere. The air particles in the atmosphere, which are moving because of winds, reflect some of this light craft. By measuring the shift in frequency of this backscatter, Aeolus can detect the wind speed and profiles at different altitudes. Aeolus is the first satellite to use this technology in space. This is why its development has been a long and costly process. The satellite is both a technological marvel and a real challenge.
We pulse our optics 50 times every second, and this goes on year after year. And this intense pulse creates 1700 degrees on the optical surface of the optics and will fatigue the optics in long run. So we've had tremendous developments of the coatings of optics, and to withstand this high pulse, laser pulse ability. We are actually our own sun, if I may say.
Despite its more than 16 years of development, Aeolus overcame all difficulties because the mission was of great importance to the scientific community, who have requested data on global wind profiles for the better part of 2 decades. Due to its low altitude, Aeolus will have a lifespan of only 3 years. However, ESA hopes the technology will be continued on similar satellites in the future, as the understanding of wind profiles is a key factor for meteorological and clouds which benefit us all.
During the film, we will pick
Saint
up
Hubert has
the next
acquired.
downrange tracking station. You see it on top, Saint Hubert, Canadian Air Force Station in Quebec, also used for Soyuz, by the way. It'll track Vega until the first
I presume Soyuz launches
Martin, in the film,
out
they talk
of
about 16 years development, overcoming difficulties. What sort of difficulties?
damn you brain
Well,
out
at the
of
beginning we
Kourou.
had a working laser on the table, and then we put it in the vacuum, and it stopped working.
Bad news.
Bad news. So then it's okay. We all thought that this is the end of it.
What? The end of the project?
We thought the end of the project because we put the laser in the vacuum chamber, and within no time the laser stopped completely working.
So use the project. Everybody panicked. We'll find out what Martin's teams did to fix the situation after the next film on the prime contractor Aeolus.
Il reste 2 minutes 30 de poussée de la voûte. pilotage est calme, tous les paramètres propulsifs sont normaux. Il reste 1 minute de propulsion de la Voom.
So I presume that
So
means 1
before
minute
the
left of the
Airbus
Avloom
film,
burn.
you were telling
Burn.
us
Come on,
the
I can
project
speak.
looked like it was off a cliff. What happened? How'd you fix it?
Well, we realized that the difference was ambient or vacuum, and that was the lack of oxygen. So we realized, wait a minute, maybe we need oxygen. We did a few tests, we applied oxygen, and guess what? It worked.
It worked. Now, not one of many technical challenges. You mentioned some other ones that you had.
One of the things we had, we invented the in-situ cleaning system to supply oxygen, but no one had built that before, so we needed to find components that could do that. For instance, pressure transducers that work under high pressure oxygen, but also low pressure oxygen, did not exist, so that all needed to be developed.
Now this because the Aeolus being part of the Earth Explorer system, or ESA, Earth Explorer missions always using groundbreaking science.
Avloom was shut down, I believe.
So this is part of the, must be very exciting, must be very frustrating.
It's always on the edge of technology. We're always on the boundary of what we can achieve.
I presume that means beginning of the ballistic phase.
Successfully after its first 8-minute burn.
L'orbite atteinte à la fin du
And you see
premier boost
the
à Voom
composite
est
being spun
nominale.
up. Some of the benefits of Aeolus, we've been talking about them a little bit in the films. What's it going to bring to the average person?
But the benefits is that we will have much better weather prediction, so that we can, if there is let's say, high winds or a hurricane or something like this, we can better predict where to put the resources in order to recover the situation.
This mission, the 120th satellite, built for launch by Aeolus Airbus, getting back to the 20 more Airbus spacecraft remain in the Ariane Space Manifest.
Times it's probably going to be more.
Fifth mission for Ariane Space this year. We've done 3 Ariane 5s and a Soyuz so far. The 299th launch for the Ariane family. Aeolus being the 27th satellite launched by Vega, and the 583rd satellite launched by Arianespace. Some interesting numbers for you. Going back to orbits, our sun-synchronous orbit, most Earth observation satellites have to go into this orbit. Heliosynchronous, why is that?
The thing is, you want to have a global coverage with Earth observation spacecraft, so then the only way to do it is with a polar orbit.
Because, why, does the sun light have anything to do with it?
No, that depends a bit on the mission. For us, for the measurements of the wind, it was necessary to be in the dusk to dawn.
We're going to go now to a replay of the liftoff. You can relive those very exciting moments. You see 3 seconds, and she's gone from the screen, as I mentioned. We have several observation sites across the space base here. Have cameras.
We watched these in the middle of the second burn
from their different
and separation.
These shots you're seeing now. Many of the
Aeolus.
Have you seen the launch from there?
I just saw last in July the launch of the 4 Galileo spacecrafts.
And how does it compare with the one you just saw?
Really different. I mean, the Ariane is much larger and slower, but the sound is more intense.
Yeah. And the sound from the launch base takes about 90 seconds to come here. Where we are in Jupiter. Is it the same for the Vega? Because I've never seen.
No, it's less of a delay between what you see and what you hear.
Does that have anything to do with the Doppler effect that you're talking about?
No, it's mainly the distance.
Yeah, I was about to say, they have not one from the same side.
All right. Over the fine shots of the replay, we're going to
hey, I can see my house from here.
We're going to cut away for about 20 minutes while Vega enters a ballistic phase, waiting for the second Avloom ignition.
And so will I. So
after that. So enjoy the break.
See you then.
We'll be back at about plus.
Okay, we're approaching the ignition.
A new site in 1964, there were many possibilities, including Australia and Scandinavia. Kourou got the nod because it got a lot of advantages. A large opening on the ocean, a low population density, nearness to the equator, and nearby hills where you can put installations for radar and telemetry. And you're looking at shots of the nearby hill where the CVI, also called the Real-Time Visual Center, is located right here. There's a lot going on there. These buildings are located just behind us here in Jupiter, in Kourou. And the hill is called the Montagne des Pères, the Mountain of the Fathers. Now, these teams are analyzing the data as it comes in from all the ground stations along Vega's flight path. Remember, we've been talking, and the Bermuda Islands and all the rest. These data are then treated to reconstitute the entire mission. And after that, the entire flight is recreated in figures from liftoff to well after satellite separation, then analyzed again in delay time. So all that to say that Arianespace has a huge amount of information in its archives. How each launcher, going back to the first Ariane 1, Christmas Eve 1979, performed. The first UV laser, that's something that you wanted to talk about. Now, what is that? That's part of the light of the Doppler
Yeah,
light?
exactly. We are the first spacecraft that brings its own light source in orbit.
Okay. The DDO has just called out the second ignition of the Alum fourth stage. That's going to last for 20 seconds. Go ahead, sorry.
So it's also something that Anders Elving, the project manager, has said in one of his videos, is that we are the first spacecraft to bring a light source on board. That's not done before. And it's quite unique in the sense that we emit our own light.
And the DDO has just called out the extinction of the second burn?
Okay, good. So we have our own light source, we emit and receive.
Manœuvre d'orientation avant le boost RAX.
Oh, sorry, I thought I had to wait. So, and that this is a first. So all the other agencies and programs have tried it, and they stopped because of all kinds of difficulties, because the laser is so powerful that you get all kinds of issues.
We are coming up on separation in under a minute. Can I ask you what's going through your mind now? Are you as emotional as you were at liftoff?
Well, this is going to be the moment that Aeolus will stand on his own to become an adult and go to work.
She's already an adult if she's 20 years old.
Yes, a young adult.
Yeah, or an old adolescent.
Yes.
All right, so you're feeling good.
I'm feeling good. Yeah. I'm feeling still a bit emotional, and it's quite strange, the feeling, and looking forward to the solar array deployment later on.
All right, this is, for Martin as for all of us, a moment of high concentration here in Jupiter and, of course, elsewhere around
as we wait for separation.
For the Aeolus people, as we await separation. We focus. We've gone through separations before, but it's never quite.
Et séparation Aeolus.
Yep, there's separation. Both on the animation and has been confirmed.
Separation, you hear the applause, you see the people smiling. That's the scheduled separation. Looks good. Assuming we're going to have to wait until confirmation, of course, when we get the signal from the Troll station in Antarctica. But let's assume that all is well. So congratulations.
Thank you, Joshua.
Your work is just beginning, or is it over?
In essence, it should be over now, because it's being taken over by our colleagues in ESOC. If they need me, it means that they have an onboard problem. So let's hope.
So that they don't call you.
Exactly.
We are waiting for confirmation, as I mentioned, confirmation of the acquisition of the signal from the Troll ground station in Antarctica. We want to wait for full confirmation, just to see if separation has occurred properly, that Aeolus has been sent on its proper orbit, that its solar arrays are going to be in a position to be properly deployed, that the satellite's overall health is good. A few important items, I imagine, that you have to check before we can let the satellite officially start its life and work. Arianespace and ESA, of course, taking no chances, being very thorough. While we're waiting for the information to come in, here is another play
of the launch.
There will be a third Avum burn, which is usually the case. We won't see it. It'll be in about 2 minutes. It'll be of about 2 minutes, I should say. And it'll be for passivation. You know about passivation? That's when it takes place at a much higher altitude, and the lift and the fuel of the upper stage tanks are emptied. So the satellite poses no danger to anything. That's another Avum burn to put it into a slot there. But again, we won't see that. And also looking at There will be a first post-flight analysis of the mission. We mentioned the archives. In the afternoon at the CVI, the Real-Time Visibility Center we saw earlier, there will be a technical review and a final post-flight review. On the phone, Anders getting his information from down. There will also be a post-flight analysis meeting, usually at Arianespace headquarters in Paris. So we're still waiting for the official confirmation.
That's good. That was launch of Aeolus on a Vega on bunch. I can't be asked. Wait, goodbye.